So let's give him a big round of applause.
Alright, thanks guys. Audio good? Okay. So for my understanding, how many people here are students? Alright, about half. And how many working professionals? Everybody else. Okay, alright. So considering there's a large number of students with us, I will, the entire presentation that I had planned, I'm going to just dumb down a few things, right, for the benefit. But don't worry, there will be takeaways for everybody, okay? So if you want to go or digress into any particular point that I'm talking about, we can take it up in the questions. Fine? Alright? Okay. So what are we going to talk about? One of the things that I have to do in my job is solutioning. That means different people come to me with different problems. We had a very interesting problem statement come to us recently, which is, can you put together an application for us, but it needs to have pretty much everything. So I'll explain what I mean. It's the organization is spread across 180 countries, right? So they said anybody from across the world accesses our website, it should be blazing fast. Then they said, but we also want people to be able to log in and do things on our website. And based on the country that they're in, it should be a very different experience. Okay, so regionally it needs to change. And the third thing is, the organization was driven by events. So they had very viral load. That means if there was an event happening, there were lakhs of people visiting the website, and if there was no event happening, there was probably nobody on the website. So now that brought about some very interesting problems, right? How do you solve for this? So that's how we started cracking our head. And just with this very simple problem statement, let's go about looking into what we can do. Alright? In case you're wondering, okay, what the thing people can do is, since we're at the Book My Show office, let's consider they could book tickets. Alright, book tickets for say workshops or events. Okay? Oh yeah, I forgot one thing. They had one more criteria. Everything needs to load in under a second. Okay, so I've written sub-second latency. So why should you listen to me and who am I? I've been running engineering at Proximity Works for the past 3 years now, and I have a reasonable amount of experience now. So I've been very lucky to work with India's largest OTT provider, India's largest fantasy sports app, and big companies like NASDAQ, help them on web performance, help them on problems related to scale. So millions of daily active users is something we've always considered, right? And I love indie hacking. So on the side, I built a lot of side projects to get to know what's the latest in tech, and that's why many of the things that I talk about now is like me and it's not only me, it's a bunch of people who love hacking. All of us will kind of keep checking out this tech. Disclaimers, very important. So everything we are going to discuss is cutting, bleeding edge, right? So it's very possible that the tech that we talk about is not relevant tomorrow. Okay? The concepts that we talk about is not relevant tomorrow. This keeps changing. I know this is React Mumbai, but it's very important for front-end engineers now to also have a working understanding of different aspects of where the project is hosted, where it's actually, talking to the database, etc. So think of this more as a full stack talk, all right? And finally, do we really need to talk about this? It's 2023. 40% of the internet still runs on WordPress, right? If you ask somebody, I want to build a website, especially अगर uncle या कोई होगा, तो they will be like, हाँ, गली में है ना वो 2000 रुपए में बना के देगा website. So WordPress is still a huge deal, right? It's still out there. So do we really need to talk about this? So we'll look into that, right? Keep that in the back of your mind, but always remember one golden rule, okay? Make it work, make it right, or as front-end developers say, make it pretty, and then make it fast, right? We tend to over-engineer, and we tend to want to make it fast right from day one. The only reason I'm talking about this at the solutioning stage is I am taking for granted that the first two steps we can do because we have tons of experience in making it work and making it right. Alright? Okay. Alright, all set? Okay, so first up, front-end framework. What are we going to select? So what are the things we're taking into consideration? Speed, obviously. Performance, obviously. Bundle size. So once you've shipped your application, it needs to work lightning fast. Everyone here has heard that if you want to build a marketing website, React is probably not a good option. Have people heard that? Oh, okay. So many heads nodding. Alright, so this is a very popular interview question. Huh? If you want to build a marketing website, is React a good option? Why? Because many people think about React as create React app. And what happens in create React app? You get your entire bundle size shipped to the browser, right? So it looks cool. Oh, look, I can statically host it. I have infinite load. It's okay, I'm paying pennies. I don't need to run a server. It's all hosted on a CDN. Alright, I hope you will understand what I'm saying right now. But you can ask questions. There are no dumb questions. Right? So, taking all this into consideration is, hey, we're going to have viral load, let's just put everything on the CDN. But probably not the best idea. So, it's a good idea if you can also server-side render some of your code. So, to keep in mind bundle size, community and developer experience, very important. If you have an app which is going to span across 180 countries, you're obviously going to have local developers in every country which will be building local features, like integrating with the local payment gateway, right? So you need to have something that talks to everyone. And then finally, it needs to be future-proof, right? It shouldn't go out. So obviously, our go-to guy, React, right? He was the first thing that everyone considered. But then came in Svelte, alright? And Svelte, between me and my engineering team, we absolutely loved it, alright? Those who don't have experience with Svelte, just know one thing, that there is a compiler built in which allows you to ship much lesser code. So now that gets very exciting from a speed and performance point of view. And then came in someone else, Solid.js. So Solid.js actually it takes concepts from both React and Svelte, and it allows you to write or think like React, but actually has some of the compile looking time principles from Svelte, and so you get a much smaller bundle size and you get the same speed as you would on Svelte. So Svelte and Solid.js are definitely faster. But there is something very important called a seeable difference, right? So then, from a DX point of view, engineer's point of view, अरे 100 millisecond बचा लिया, 200 millisecond बचा लिया. It's amazing, right? But if the user cannot perceive that difference, it's not useful. And it will also have a detriment on developer experience. Every new developer coming in will need to hunt for the community, will need to hunt for problem solving, right? So finally, we went with React, alright. So if you're going to start a new React application today, what do you use? Next, right? What did Next do really good a couple of years ago, because of which it came onto the market in a big way. It popularized a concept. It didn't introduce it. It was actually introduced by somebody else, but it popularized a concept called incremental static regeneration. I don't know how many people know about it. I'll talk about it briefly. So, the rendering strategy that you have along with your React application is very important. Now, mind you, many of these can apply to other frameworks and other deployment strategies as well. So I'm talking about it generically. So first things that you need to know is, depending on where you're deploying your application, there is going to be some pre-rendering that happens. What is pre-rendering? The moment you have uploaded your code to wherever you're going to deploy it, the server is going to run a build process, and it's going to pre-build some of the pages of your code, right? So that's pre-rendered. Now, one way you can serve your pages to your users is client-side rendering. So, what's a good example for what you can use for client-side rendered applications? Anyone? Okay, or rather, Ulta, what should you not client-side render? Any guesses is also fine. Okay, let me ask a more direct question. Yes or no? Should I client-side render my marketing page? No, okay. Should I client-side render my app page? App page. So, like, after I've logged in, I have an application. Maybe yes. Alright, I like that. Okay. So, yes, I like the way these guys are thinking. Marketing page, don't client-side render it. Why? Because if you client-side render a page, that means your browser is doing all the heavy lifting. That means you're shipping all the JavaScript to the browser, then the browser is doing the heavy lifting. Okay. So if you don't client-side render, then you server-side render. Now, React has a new concept. Everyone's heard about it, probably no one's used it. It's called server components. Exactly. Server components allow you to write code that should run on the server in line with your components, right? Sounds fascinating, but a lot of people are frowning upon it. Why? You shouldn't be talking to the database right next to your UI component, right? A lot of things could go wrong. So it's very difficult for people to digest this concept. On one hand, it makes you move really quickly, but on the other hand, people are, should we use our components or not? We're still in discussion with this, and finally, this is all in like alpha right now, right? So you're supposed to use it with like warning signs. The whole concept, the APIs are changing constantly. So of course, we're not going to use server components, but we will consider streaming server-side rendered code in. So what does that mean? I have a page. Again, I'm taking an example of a marketing page. My hero section is going to be pre-rendered, right? It's not changing, but the rest of the page can actually be streamed in and rendered server-side. Why will I want to do this? Hybrid rendering. So a little bit pre-rendered and then the rest server-side rendered. For the simple reason that now I'm shipping even less code to the browser, so my initial load time is really quick. Make sense? And then the second thing is, if I have some cool, component which actually has dynamic data in it, like let's assume I have, Book My Show website, I have, upcoming movies in your area. I can actually find out things like, hey, where is this person making the request from? Now let me fine-tune the response according to that person's area, and then send an API back, and right on the landing page you can actually have server-side rendered data, so it will render relatively quickly, and it will stream the HTML down. Okay, so you can have this hybrid approach, and you can look at how you to do it through the next year's talks. Finally, there is something called incremental static regeneration. Now, there's going to be a bunch of pages which never change. Great example is company blogs, right? News, marketing. Incremental static regeneration is essentially a static page created beforehand, but controlled by a content management system. So when you update the content management system, you can also update the page. So it's a static page, but it feels dynamic. How come? Because it has an expiry date. So every time, let's say I have 200 people visit my website every minute, normal server-side rendered page would actually hit the server would hit the database, right? And then you would get a response. What's faster? Faster is a statically generated page. That means the page is ready. The moment you make a request, the page is up, it's ready HTML. So what incremental static regeneration does is, it says, wait a second, this is a page with dynamic data, but not that dynamic. So let's allow the person to hit the page, we serve the page right away. Why? Because we've statically generated. But in case the data changes, at that moment, we will regenerate the page and we'll keep it ready. So maybe the 201st person, or after a minute, let's say our page has an expiry of 1 minute, after 1 minute, I'll again make a request to the database and check, and I'll rebuild and keep the page ready. That means in a day, if I have lakhs of users, actually I'm only building my page once every 2 minutes or 3 minutes. This is very efficient, right? That means I'm still using the CDN infrastructure, so I can still scale endlessly, and my server is barely having any hits. Okay? Because I can predict exactly 3 minutes में एक API call होने वाला है, one API call, even though there are lakhs of people, right? So it's very interesting. Alright, so we're going to take all of these, and these rendering strategies are important going forward. Rest of our infrastructure. So now, this is where I want to get out of the front-end thinking mode and start thinking a little bit about the whole stack. So, you're going to have some servers. When I talk about servers, I mean dedicated machines, BPS. Okay? Digital Ocean Droplets, Amazon EC2 instances. Alright? Okay, fine. Apache, Linux. Okay. Serverless. What do I mean when I talk about serverless? Everyone just remembers one thing. AWS Lambda. Okay? That's a good reference point, but you should know that there is something else also called edge serverless. There is a very big difference. We'll look at the difference today. And finally, your database. More and more people have started disconnecting the database from your server. It was very normal, even up to 5 years ago, it was very normal to have your database and your server sitting on the same system. The reason for this is very simple. Because your database and your server are sitting together, it's lightning quick responses, right? Because your node service or host service is making a call to the database and it's literally sitting on the same service. But scale is an issue. Second, you can compute your service down to 0, right? This is a possibility now. You can actually turn machines off when people are not requesting your service there. Or you can scale multiple machines horizontally and you can scale them down. So people have, and of course you have a lot of microservices. That means same database, but I have a different analytics team. I have a different business team or product team who want to look at data separately. So I have all these different APIs and they're not the consumer facing APIs. So I need my database separate from my API service layer, right? So people have been kind of breaking things out. Alright, with this prerequisite knowledge, let's just look at what mistakes and design patterns we generally see. So first is, I have my user sitting in India and I've deployed everything on Amazon EC2 US East. Got it? So what's happening? And it's database right next to the server. ठीक है, एक machine पे database भी डाला है, server भी डाला है. अरे, such quick response. What's actually happening? Is it quick? So for all of these examples, no, we will just talk about response times, okay? It could be API response time, it could be getting a response of a rendered HTML page. Both are possible, right? Don't forget a server can do both. Server can give a responsive API also, server can also give you a rendered HTML page also, okay? Alright, so obviously this is not a good setup. Why? Because this is not co-located close to your user. So this is going to be slow. How slow? Anyone knows how to calculate how fast you're going to get the response over here? Any idea? Okay, so fun fact. What do we know the technology that's used to transfer internet across the world? Fiber optics. What does fiber optic depend on? Speed of light. So that's how you calculate the response times. Okay, you calculate the distance light has to cover as the crow flies, and you get approximates. So this round trip will cost me somewhere in the range of 650 to 850 milliseconds. That's close to a second. That means come what may, I'm going to take at least a second if you add processing time, etc., to actually see the response. Right? Okay, what's the problem? Actually, if you think about it, 10 years ago, there was no problem. 1 second में site load हो रहा है, अच्छा है, ठीक है, कोई बात नहीं है. I can have one server, I can control scaling across the world, I have users. Believe it or not, this is how most applications work even today. And it is a perfectly fine solution. The problem is when we have got used to really quick responses. So more and more businesses are reporting that if my website doesn't load in 2 seconds or 3 seconds, I start losing customers. Right? So for that reason, we need to load really quickly. Okay, so let's replace server with a serverless function. But serverless function has to be hosted somewhere, and when we set up the Lambda, we chose US East. So has it made our system any faster? Not at all. So this is one very important thing. If you're using serverless functions, co-locate your serverless functions where your users are. Alright, I'll tell you what now. Let's go even more cutting edge. Let's use serverless edge functions, right? The whole point of edge is it's close to the user. Okay, this is fantastic. Now the edge function is right next to my user. I'm going to get an excellent response time, but my database is hosted in the US. So what happened? Did this improve the situation? You know what? This setup is actually slower than having a dedicated server, because now you have more moving parts. Alright? To give you an idea of how slow this is, you will get an immediate response that you hit the server within milliseconds, because now you're hitting a machine in India itself. But your actual response from the server will come about 1.5 seconds later, or maybe about 1.1 seconds later. Okay. So, you know what this is? If I'm running a ticketing system for India, this makes a lot of sense. Trusted dedicated server hosted in India. That's it. This is more than enough to take care of all users in India. Okay? So we are talking about all of this stuff, but don't forget, make it work first. And make it work for where your maximum number of your users are. Okay? So this is actually faster than this, obviously. Acha, there is one more aspect here. We like to call this the N+1 problem in the industry. When your user makes a request to the service layer might actually make multiple requests to the database and then respond back. Make sense? I need to go check if the user is there. Now user is there, then I want to go and do something. Acha, user is not there, create the user, then send him welcome email. and then only send response back, by user created. So I need to make multiple calls. This is called the N+1 problem. What happens when I need to make multiple calls in this sort of a setup? The problem gets highly aggravated. Responses which should take 1 second now take 5, 6, 7 seconds. Does this make sense? So many times you've been on a website, the loading spinner just keeps going. The rest of the website is pretty quick, but 1 or 2 interactions take a lot of time. This is generally the issue. Alright. So we've solved this problem. Now, since we saw that the database is also an issue, and Edge serverless seems to have solved our service layer problem, let's look at some options for our database. So what we would like is a globally available managed database. So there are a bunch of options available today. I am specifically talking to the front-end developers here. It's becoming easier and easier for us to deploy our own functions and write back-end code which is co-located to our front-end code. So it's also becoming easier for us to choose a database solution which also scales virally, right? Remember, one of the important things was scaling virally. With serverless, Edge serverless functions, we can do that. We don't have to worry about hosting. But with databases, how do we do that? We do need to take care of a few things, right? Actually, people are providing managed solutions. So AWS RDS is probably the most popular, the most tried and tested, but it's costly. Google and Azure have offerings as well, again, costly and complex to set up, right? We are all used to Vercel, right? We are all used to Netlify. Just point us, click, Git, integrated, we're done. We would like something like that. Signed in, no credit card details, I have a database spun up already. It's just limited, but I can try it out. So all the other services are actually providing you that. If you're comfortable with MySQL, highly recommend PlanetScale. It's amazing. It handles running multiple servers across the world for you. It even detects, actually most of these services detect where your requests are coming from, and then it runs read replicas in those areas, right? So it kind of takes care of your users, situation scenario for you. And then making a huge entry into the space is SQLite. Now, a lot of people thought SQLite is file-based database system. मेरे कंप्यूटर में मुझे कुछ टेस्ट करना है तो ठीक है, लोकल कुछ रन करना है तो ठीक है. It turns out SQLite scales like crazy, right? It's insane how well it scales. So a lot of people have been investing in a big way in running SQLite across the world, and people have been able to, because you just have to duplicate a file, people have been able to make this globally available really quickly. So there are a lot of amazing options. Again, this is all alpha stuff, but it will soon be available to everybody. Check it out if you're interested. Just to give you an idea, a setup with Cloudflare Workers. Cloudflare Workers is the Edge serverless provider, and talking to a Cloudflare D1 database, I can get a response in 70 milliseconds. Just to give you an idea of what that means, I never see the loading spinner on my screen. This changes the game. We're talking about spans, we're talking about, all these ways to kind of ensure that the data is loaded properly and the user gets the right experience. Imagine you don't even have to do all of that, right? So this is why this is really interesting, right? And if it's at 70 milliseconds, maybe for the worst person in the corner of the world, furthest away from the machine, at least 700 milliseconds. But that's still pretty cool. All right. So look at how managed databases work. I have a master database, and then I have read replicas all across the world. And my user is now not just the user, it's user and Edge serverless function. And now my Edge serverless function is just reaching out to the closest read replica, getting the data coming back, So all my users across the world are getting sub-second latency. Pretty cool, right? Okay. But what if my user needs to make a write request? So now there's a unique case where I don't, but let's assume payment के time, right? Ticket book कर दिया अभी, right? तो करना पड़ेगा ना. I want to maintain one database. कितने लोग सारे workshop में, movie में, I have to make my write back to the master database. So write requests will obviously take longer. Hence, on a lot of websites, when you're making your payment, it takes a lot of time. Of course, it also takes a lot of time because there are a lot of intermediaries. But this is another reason why it takes a lot of time. Alright. But serverless is not a catch-all. Serverless is definitely not a catch-all. So what do you need to look out for? Number one, computational limits. You cannot run everything on it. Why? Because it needs to be able to spin up quickly. So, image processing. Something you can do on serverless, but something you probably can't do on edge serverless. Make sense? So if you're thinking, okay, CRUD operations, right? Yes, CRUD operations, great to run on serverless functions. Memory and space limits. So CRUD operations, but not with humongous outputs. So everyone here must have tried integrating with OpenAI's API. Not a good idea integrating with OpenAI's API on a Cloudflare worker. Why? Very huge response. And it will take time also for it to come. Another thing is, there are time limits on most serverless functions. It would like you to finish all the activity in 30 seconds. And finally, no access to the file or folder system. So you might want to mess around with the file folder system. You don't have access to it. Alright. One aspect we have not spoken about is the backend framework that you choose will have one more important part. Since you're all JavaScript developers, I've just added this little tidbit of information which is very useful. If you have not yet used Prisma, try it out. It's probably the best developer experience you can get in your backend to talk to your database. So you have a Node Express server, you have a Apollo GraphQL server, or you have a Nest.js server. Again, I'm assuming you're JavaScript developers. You're all probably going to want to use Prisma to talk to your database, right? There's a problem. Prisma ships with its own Rust engine. It means your backend with Prisma is too big to be hosted on an edge serverless provider. So while you have an amazing developer experience, you just can't. Infrastructure limitations. So at that point in time, you have to shift for an alternative. Right now, the popular alternative is Drizzle. Right? You can again check it out. I have a very fun Twitter where they keep tweeting if people who complain about Drizzle, they keep retweeting only those tweets. Okay? Because they're like, हम नहीं चाहते लोग यूज करें, हम अभी भी डेवलपमेंट में. Okay. But anyway, the cool thing is you can actually run Drizzle in serverless functions. So it's very, very fast. Again, you want to optimize every single aspect of your application for bundle size. So you might not choose Express. Express is heavy. You might actually go for something super lightweight. So in case you guys have heard of it, there's something called Hono, H-O-N-O. So Hono.js is very popular right now in the workers ecosystem. Okay. So taking all of these concepts and tying it together is a very interesting solution right now in the market. You may or may not have heard of this. This is SST. SST.dev is the website where you can check this out. What they're saying is Amazon already has solutions to all of these problems, right? I'll tell you what we'll do. We'll take care of provisioning it and hosting it, but we'll give you a CLI to run it off. So you don't even log into Amazon's GUI and get confused कि कौन सी चीज़ कहाँ provision करनी है. So they're very straightforward, tool. But what they're trying to do is they're trying to provision everything for you, from S3 buckets to CloudFront to your Lambda to Edge Lambda everything they're trying to do for you, and they're trying to take care of all of this provisioning. One thing I really like about this is highly modular. If I have an app tomorrow that I don't want to use React, I want to use Svelte, I can actually still use these guys. We internally have been building our own, we like to call it App Factory. This is very, very early stages, alright? So we want to kind of build a repository that we can use to spin up a globally scalable, viral application which will run for 0 to 10 rupees a month, right? So practically within the 3 tiers, but it will have the scale ready to take on lakhs of people. So we put something together, but this is just a wrapper on top of SST dev, right? So soon we've been working on adding things like A/B testing and internationalization, support for multiple languages, because that's what we require time and again, right? So this is something interesting that we've been working on. I'll share the slide deck so you'll have the link as well to this. But please not, this is like our first, curtain reveal on this. Alright, so concluding our learnings, don't reinvent the wheel, right? Many a times people feel, oh, I need to do a couple of seconds improvement, let's figure it out, or I need to build this content management system. Someone's already out there, they've already done it and they've solved your problem, just search for who has, and most probably it's open source. There is no such thing as a perfect abstraction, right? So when we kept trying to build App Factory, we kept trying to make like the perfect app starter. We realized that does not exist. So we built one version of it. And we said, let's create multiple versions of it depending on what we need, right? Sometimes you might need to work with a monolithic server because that just makes sense. Sare ke sare log India mein hi hai. Why should I use Edge serverless, right? But sometimes you might want to use serverless functions. Why? Because you're working on an ERP system for a school, and schools are closed 4 months of the year. So why keep your servers running for 1/3 of the year, 1/4 of the year when schools are closed? Make sense? So you might want to use serverless in that. So there is no one solution fits all. Again, I cannot state this enough. Make it work first, then make it right, then make it fast. We love, we want to rebuild our own blog. No, it has to be lightning fast, it has to be SEO optimized. Just get that blog out first. Figure everything else out later. Your rendering strategy makes a difference. We saw that. But probably not as much as your backend infrastructure. Alright? So, the amount of difference, because I chose one rendering over the other, is actually much smaller than your entire backup for your API responses as well as your server, which is doing any server-side rendering, which you may or may not choose, right? Your entire application might just be statically built pre-generated pages and client-side rendered pages. That's perfectly possible. Serverless is not a silver bullet, especially at serverless, at least not yet. We're getting there. Okay? As days go by, daily they're supporting more and more Node APIs, and it's getting easier and easier to just port our normal Node code into a serverless function. And finally, ensure you're not optimizing in the space of diminishing returns. There is a point beyond which optimizing your app further is actually going to not help you. The amount of effort you're putting in and the amount of perceivable difference is too small for the end user. Alright, cool. Thank you. That's it.